Welcome back. In this lesson, we will explore how the symmetry of even and odd function can help simplify definite integrals. So, why should we use these properties? Firstly, remember that the definite integral represents the area under a curve. Now, if a function has symmetry, it can make the integration process easier. And importantly, this rule works best when the limits of integration are from negative a to positive a. Let's begin with even functions. A function is even if f of negative x equals f of x. This means the graph is symmetric about the y-axis. A function is even if the value of the function at some x coordinate is equal to the value of the function at the negative of that x coordinate. Let's look at this graph. Here, the value of the function at x equals 0.8 is 0.34. At x equals negative 0.8, the value is also 0.34. This tells us that function at 0.8 equal to function at negative 0.8. Same is true for other x values like 0.7, 0.6, 0.5, 0.4, and so on. Since the functions mirror itself on the both sides of the y-axis, we can conclude that it is an even function. For any even function, such as this one, the net area under the curve from 0 to some positive value of x, which we call a, is exactly the same as the area from negative a to 0. Since integrals are integrated as net areas, the integral of the left from negative a to 0 is equal to the integral on the right from 0 to a. This symmetry gives us a convenient shortcut. Instead of integrating from negative a to a, we can integrate from 0 to a and multiply the result by 2. This is why for any even function, this saves time and simplify the computation when evaluating the finite integral of even function over symmetric intervals. Let's begin with odd functions. A function is odd if function of negative x equals negative f of x. An odd function is one for which the value of the function at some x coordinates is the negative of the value of that x coordinates. Let's illustrate this with the graph. At x 0.3, the function's value is positive 0.7. Now, look at x equal negative 0.3. The value of the functions becomes negative 0.7. The same patterns hold true for any x coordinate. We choose like 0.5, 0.7, 0.9, or 1.1. For any odd function like this one, the net area under the curve from 0 to some positive value a is the same as the net area from negative a to 0, but with the opposite signs. So when we add the two areas together, one positive, one negative, they cancel out. As a result, the integral of an odd function over a symmetric interval from negative a to a is always 0. This property is particularly useful when evaluating complicated definite integrals. An even function is symmetric about the y-axis. The left and right sides are mirror image. So when we integrate, we add both sides together. An odd function has symmetry about the origin. The left and right areas are equal but opposite. So when we integrate, the areas cancel each other's out and the result is 0. Are you ready to learn the important properties of even and odd functions? Let's continue this journey together. See you in the next video. Thank you for watching.